On 7b, we're applying what we saw on 7a to do some math. Here we have a salt. The salt has a certain concentration, and we want to know what is the pH. So the important pieces to this is recognizing that sodium's from sodium hydroxide, a strong base, and has no acid or base properties. Fluoride is from hydrofluoric acid, a weak acid, and therefore is a weak conjugate. They will have to give you somewhere a K value to be able to do this. But what's important is this could be a multi-step free response question where it isn't plugged right in where you think you may need it. You may need to search back to a previous part, or if they're not asking for a specific number in terms of the pH, just if it's acidic or basic, it may not give you the Ka. But the Ka is a huge indication in the fact that they're asking about the pH of an ionic compound. So what I think about is that fluoride was the weak base. Bases accept hydrogen ion, turning into a conjugate acid, and the hydroxide ion. The K for this expression is products over reactants. We're ignoring water as a pure liquid. And what we need to recognize is because hydroxide is in this, the K expression is a Kb expression, not a Ka expression. You're going to have that extra step when you're thinking about salts. We are given the K for the original solution or the original acid or base, but we are looking at its conjugate. The way we make the connection is that Ka times Kb equals Kw, which at 25 Celsius is 10 to the negative 14th. So if I know how strong or weak my original acid was, I can calculate how strong or weak its conjugate is. So the Kb for the conjugate base of HF is equal to 1.5 to the negative 11. The Kb expression we've already written up here, but we don't need to write our rice table. It's x squared over molarity. Here we have our K, we've got our molarity of the fluoride ion, we've got our x's, and we remember that the x in this case is the concentration of HF and the concentration of OH minus, which is a fairly small value. When we think about that as being hydroxide, we know to get to a pH, we have to change it to hydrogen ion. So we once again use our 1 to the negative 14th. We get our hydrogen ion, and the negative log of that is our pH. So these problems have lots of steps. It is very rare that you'd have to do all of this. Write the reaction, write the Kb, find your Kb, plug that in, change it to H plus, change it to pH, all in one step, just because that's so much work. But any pieces of this can kind of be put together, and you can progress through them all together in a multi-step free response, or in multiple choice. Maybe you don't have to do all of the math, but you have to do enough to make an estimation of where the pH should be. Should it be above or below 7? How much above or below 7? So being really familiar with using the Ka relative to the Kb, knowing that it has to be the Kb expression, and the connection between OH and H plus is very important when thinking about the pH of ionic compounds or salts.